Today we are going to discuss about L by D1 ratio. The question is that what is the requirement of L by D1 ratio? In this lecture we are going to understand the requirement of L by D1 ratio, where L is the length of the shaft and D1 is the L is the length of the bearing and D1 is the diameter of the bearing. Here I draw three cases for the L by D1 ratio, and where D1 is the diameter of the bearing and L is the length of the bearing. When the ratio L by D1 is less than 1 or L by D1 ratio is equal to 1, then we use the formula for the calculation of the load is of simply supported beam. We use the formula to calculate the load for bearing of simply supported beam. For point load, the formula will PLQ by 48 EI, and for UDL means uniformly distributed load, will 5 by 5 WL to the power 4 by 384 EI. When the ratio is less than 1 or equal to 1, then we use the formula for the calculation of various condition or load of simply supported beam, but this ratio will greater than 1, then we use the formula of the fixed supported beam. Here I write the formula for the point load and uniformly distributed load. The difference between the point load and the uniformly distributed load for simply supported beam and the fixed beam, if we want to write the formula of the point load, then we write PLQ by 48 EI. If we want to convert this formula into fixed beam, then we divide or multiply this formula by 1 by 5. And same in case of UDL. If we want to convert this formula of UDL of simply supported beam into fixed beam, then we also multiplied by 1 by 5. Then this 5 get cancelled and this formula will converted into fixed beam. This is general information for the SOM, that is strength of material. So the question is that what is the requirement of L by D1 ratio? When we calculate coefficient of friction, which is given by MC key equation, this equation is developed by MC key brothers. So by the name of the two brothers MC key, this equation is known as MC key equation, and from this equation we calculate coefficient of friction. The coefficient of friction is a function of Zn by P, where Z is the viscosity of the lubricant and RPS means round per second. Generally, when we calculate other formula for the bearing and the shaft, then we used RPM, but here the value of the Z in RPS, where S is a second, P is the bearing pressure, D is the diameter of the shaft, C clearance between the shaft and the bearing, L is the length of the bearing, and D1 is the diameter of the bearing. So coefficient of friction is a function of Zn by P, where Zn by P is known as bearing characteristic number. And if we want to write this formula or this MC equation in term of formula, then we can write mu is equal to 2 pi square Zn by P T by C plus K. The ratio, that is L by D1, is useful in this equation to calculate coefficient of friction, where this K is known as leakage factor. If we calculate the value of L by D1 ratio, this value is, if varies from 0.75 to 2.8, then we use the value of K is 0.02. If this value is greater than 2.8, then we use value of K 0.03. So these are the requirement for the L by D1 ratio. For get purpose, the useful formula for the coefficient of friction is up to d by c ratio. Mu is equal to 2 pi square Zn by P d by c. This formula is useful in get, and for usefulness of this formula, IAS is complete formula. Will useful in the conventional question for the IAS, but up to d by c ratio this formula is useful in get. So this is about, or this lecture is based on D1, where D1 is the diameter of the bearing, L by D1 ratio, and the various condition we discussed, that is if the ratio is less than 1 or equal to 1, then we used to calculate load simply supported beam formula. If this ratio is greater than 1, then we used fixed supported beam formula for point load for UDL. We want to convert simply supported beam point load or UDL into a fixed beam, then we multiplied this formula by 1 by 5, then we can convert fixed simply supported into fixed beam. Coefficient of friction is a function of Zn by P. Zn by P is known as bearing characteristic number. We also use one more formula for the calculation of bearing characteristic is Summerfield number. This is Zn by P. We also use Summerfield number. D by C, L by D1. D1 is the diameter of the bearing, and built on RPS, that is round per second. And the formula for the coefficient of friction is 2 pi square Zn by P d by C plus K, where K is leakage factor. If the value of L by D1 ratio in between 0.75 to 2.8, then we use the value of K 0.02. If this ratio will greater than 2.8, then we use the value of K is 0.03. So this is about L by D1 ratio. Thank you.